Okay, we're going to do a short lesson today about rationalizing the denominator. This is a process that we use to get a radical expression out of the denominator of a fraction. Because it's irrational, the radical is we don't want it in the denominator of a fraction. It's not simplified. So to do this, we use a concept that has to do with squaring and square roots being opposites. When we multiply a radical expression times itself, we are squaring it. And of course, you multiply underneath the radical, you end up with the square root of 4 here, which is a perfect square, and you can take the square root of 4 and make it a plane 2. By multiplying the radical expression by itself, you square it, you square out the radical, the square root, because the squaring and the square root are opposite operations, and you end up with the same expression that you had under the radical as the bottom of your denominator when you do this. Of course, with fractions, we do the same thing on the top that we did on the bottom. This is just another form of 1. It's the same thing on the top and the bottom, so you're not changing the value of the fraction you started with, you're just changing its form by multiplying it times 1. So on the top now we have 1 times the square root of 2, giving us the square root of 2 on the top. Now, when you rationalize the denominator, usually you see that radical pop up on the top of the fraction instead of the bottom, but this is okay. This is acceptable in math to have a radical on the top, just not on the bottom. So this is the process we're going to use to rationalize the denominator. We're going to do a few examples. I see 7 over the square root of 6. To get rid of that square root of 6 on the bottom, we're going to multiply that fraction. We're multiplying it times whatever's on the bottom because we need that radical to multiply out of the bottom. But with a fraction, you have to do the same thing on the top that you did on the bottom. So you can see now the bottom is going to be the square root of, and you have 6 times 6, 36, which simplifies to just make a plain old 6. So you can see again that we ended up with that 6 that came from underneath this radical. This is what happens when you rationalize the denominator. You multiply the denominator, the radical part, times itself, and it multiplies out. You have to do the same thing on the top that you did on the bottom. That's just another form of 1. So we have 7 times the square root of 6. If you remember how to multiply radicals, that 7 and that 6 do not multiply together because the 7 is on the outside and the 6 is on the inside. So it just becomes 7 times the square root of 6. And this is the simplified form. I have another example, 3 over the square root of 5x. To get rid of the square root on the bottom, we're going to multiply it times itself. So we're going to multiply times the square root of 5x on the bottom. We have to do the same thing on the top that we did on the bottom. To keep that fraction equivalent, we're just multiplying it times a form of 1. On the bottom, you're going to end up with the same thing that was under the radical. I skipped the multiplying part and just went right to the simplifying part. You're always going to end up with just the same expression that was under the radical. On the top you have a 3 on the outside and a square root of 5x on the inside. I'm going to do a few more examples, so I'm going to erase these. I'm going to do 3 over the square root of 7, multiply the top and the bottom times the square root of 7, because that's what we want to get rid of on the bottom. You end up with the square root of 7 times the square root of 7 makes 7. On the top, 3 times the square root of 7 on the top. I have another example. I'm going to just draw a line here so I can put my next example here. 4 over the square root of 11. Again, we're going to multiply it times the radical expression that's on the bottom, which is the square root of 11. Same thing on the top and the bottom. The square root of 11 times the square root of 11 makes 11. It's the square root of 121. If you multiply them together, they make the square root of 121, which is 11. On the top, you have a 4 on the outside times square root of 11 on the inside. Let's draw another line. Let's put another example here. The square root of 2 over the square root of 3. Now, we have a square root on the top and the bottom in this example. It's okay. The square root on the top doesn't matter. We just need to get rid of the 1 on the bottom. So we're multiplying it times itself. And we have to do the same thing on the top and the bottom, because this is just a form of 1 here. The same thing on the top and the bottom of a fraction is just another form of 1. On the bottom, the square root of 3 times the square root of 3 makes the square root of 9, which is 3. On the top, these are both under the radical, so if you remember your rules for multiplying radicals, you multiply numbers that are underneath. So on the top, we have the 2 times the 3, giving us the square root of 6. Alright, I want to do a few more examples, so I'm going to clear my whiteboard here. I have 9 over the square root of 2y. I want to multiply this radical on the bottom times itself. Multiply times the radical expression on the bottom. Same thing on the top. This is a fraction rule. Same thing on the top and the bottom. On the bottom, the square root of 2y times the square root of 2y is going to multiply out, and you're just going to get 2y. On the top, the outside is 9. The inside is square root of 2y. And this is rationalized. I have 2x over the square root of 10x. I'm going to multiply times the radical expression on the bottom, which is the square root of 10x. Same thing on the top, square root of 10x. I think I'm going to write this out a little bit more this time. When you multiply these, they become the square root of 100x squared. On the top, outside, 2x, inside, square root of 10x. Okay, I can simplify the bottom. I know the square root of 100 is 10, and the square root of x squared is x. On the top, I still have 2x square root of 10x. Now, I see in this fraction that there's a little bit of reducing that can happen. This 2 can reduce with this 10, and the x's can also reduce. When you have x over x, they reduce to make this 1, so those x's are going to be gone on the outside there. And the 2 over 10 can also reduce to make 1/5. 2 over 10 makes 1/5. We still have the square root of 10x on the top. You could probably get rid of this 1. You don't really need it, but it's okay to write it if you want it. I'm going to erase my board again so I can do another example for you. I have 6 over the square root of 5xy. We're going to multiply, that's not a minus, it's a multiply, times the square root of 5xy. Same thing on the top and the bottom. Keep that fraction equal. Those square roots of 5xy right there, when you square them, the square root is going to multiply out. Those are opposite operations, so you're just going to end up with 5xy on the bottom. On the top, 6 on the outside, square root of 5xy on the inside. The last example, we had some stuff that would reduce, but there's nothing here that would reduce because the 6 and the 5 don't have any common factors. So you can't really reduce anything out here, so this is done. This is your final answer.